Here's the second slide that you had to come see me for U3N3 ionic compounds. And this one has calcium and fluorine. Again, calcium is your metal, it's on the left side of the periodic table. Fluorine is your nonmetal, it's on the right side of the periodic table. Now, truth be told, calcium has an atomic number of 20, a mass number of 40, so that gives me 20 protons, 20 neutrons, and 20 electrons. Now, truth be told, this isn't drawn completely correctly, but for the sake of making this easier, I fudged something, and it's kind of not as important, at least for understanding what happens when calcium and another atom share or transfer electrons. So we have electrons in the first energy level, second energy level, third energy level, and eventually out here on the fourth energy level. These electrons right here are in the outermost energy level, so they're going to be our valence electrons. So calcium is going to have 2 valence electrons. So I would draw calcium like this. Fluorine, on the other hand, is correct. So fluorine has, it's a nonmetal. It's on the right side of the periodic table, has an atomic number of 9, a mass number of 19. So that means that we have 9 protons, 10 neutrons, 9 electrons. And again, when I look at this structure, I have 2 electrons in the inner energy level and 1, 2, 3, 4, 5, 6, 7 electrons in its outermost energy level, which means that it has 7 valence electrons. So when I draw that, it would look something like this. And again, because this is an ionic compound, and in ionic compounds, electrons are transferred from a metal to a nonmetal, we represent that by transferring an electron here with an arrow, which means that over here on the product side, for lack of a better term, I have a fluorine atom that has 7 of its original electrons and then the one of the electrons from calcium. So if I go back to calcium over here and I look at this Bohr model diagram, this atom right here is not stable, or not stable as it could be, but because it transferred this 1 electron has 1 valence electron left, it's even less stable. So that means that it cannot stay like this with that 1 valence electron left, so it has to get rid of it. And it's going to get rid of it by giving it to another atom, and in this case, it's going to give it to another atom of fluorine. Now, the only options here when we're combining ionic compounds are the elements that you're given. So calcium and fluorine are the only options here. I couldn't add another element here just to make calcium lose an electron. So because this fluorine is available, calcium is going to transfer its remaining valence electron over here to the second fluorine, which is going to give me a secondary fluorine over here, which will have that second valence electron from calcium, which is going to leave me with calcium like this. So again, going back to this model, calcium had 2 valence electrons, it lost 1, lost the second one, and as you can see, this inner one right here has 1, 2, 3, 4, 5, 6, 7, 8, which means that now calcium has a stable arrangement of electrons. And to figure out its charge, we go back and we say, well, calcium started with 20 protons and 20 electrons, so that was a total of 0. It lost 2 electrons, so it's 20 protons and 18 electrons, so it has a charge of +2. A fluorine atom has 7 valence electrons. It gained an electron, so we want to figure out a fluorine atom's charge. So it started with 9 protons, and we're going to add that to 9 electrons for a total charge of 0. But because one of these accepted 1 electron, it had 9 protons and 10 electrons, so it had a charge of -1. So that means that this one has a -1 and this one has a -1. And if you see the +2 and the -1 and the -1 add up to 0, that's what you want to have happen. Now, there's one other thing that I would like to point out, is that in terms of atoms and whether or not they give up electrons or gain electrons, when you're looking at the number of valence electrons, the higher the number of valence electrons an atom has, the more likely it is to gain an electron. So anything from 7 or 6 or 5 valence electrons, probably going to gain an electron. If an atom has fewer valence electrons, like 1 or 2 or 3, it's probably going to lose electrons.